Good afternoon, everyone. It's a real honor and privilege to be here to share this exciting project. It's a project around using simulation model in a kind of a unique way. We're using simulation models for predictions. So the background is one of the largest gas turbine manufacturers in the world, and they were facing a real problem. They had about a 5-year portfolio of gas turbines to make. They were about a year or so into this, and they were starting to get signs that they are starting to deliver late on certain commitments that they've made. Do we need to panic? Yes or no? Are we going to be on time? We have quite good margins, so they were planning at about 30% net margins. If we need to, can we throw money at the problem, get additional resources and catch up? Or is it simply not possible? What's our best option? Do we need to change our commitments to our shareholders and to customers? And I was specifically worried about the backlog that was starting to build up. The sales team had gone out there. They had developed a strategic competitive advantage around reliability. They were so confident based on their past performance that they were willing to offer penalties for late delivery in return for bonuses for early performance. So the idea was we had already started developing a model that was completely self-configurable, that you can literally do a download from MS Project or any other project environment with a full work breakdown structure, all the resource allocations, the interdependencies, the times, and then of course you introduce the variability around those times, etc. And we wanted an environment to test, and this was an ideal environment to say, can we use the simulation model, read in the full project plans that they've got for their whole portfolio of programs with clear milestones and key deliverables, and essentially press the play button. We have created a digital twin that's going to help them to check, are we going to be okay, yes or no? And if not, by how much are we not going to be okay? How late are we going to be? And what's the financial and operational impact as a result? We know that it's a major challenge for any manager today because not only we have to make tough decisions, we have to make tough predictions. And why is it so tough? Because we have to commit to lead times, to budget, to scope. And it's extremely hard to do this when we are looking at the VUCA in this environment. Lots of volatility, lots of uncertainty, lots of complexity, lots of constraints, and ambiguity around what are the main target objective functions. Are we going to go after time? Are we mostly interested in scope or budget? What is the combination of these? And then on top of that, we know that these systems are nonlinear by nature. Big changes could have very small impacts. And very small changes can sometimes have big impacts. The current tools that they had, Microsoft Projects, other project planning systems, their ERP systems, and others were simply not capable of answering these type of questions. And they needed to come up with an answer and do so very quickly. Why simulation? Because we can build a digital twin that's at the level of good enough to be able to give us that kind of magnitude of answers. We've been trained that it's better to be approximately right than precisely wrong. We wanted to give them a model, a digital twin of their environment that would help them to be approximately right. Are we going to be early? Nothing to panic about. You've just had a bit of a delay, but you'll be able to catch up. There's enough buffer in the system. Or you're going to be about on time, or you're going to be late or very late. And what's the financial impact of that? Are you going to make about the profits that you estimated? Are you going to make more, less, or a lot less? They simply didn't know. And what we wanted to do is to show them what will happen using this digital twin that we've built from the environment if they don't change the project management practices. The big challenge that they didn't know was how much WIP in the system should they tolerate. They had a portfolio of thousands of phases that are all required to make up hundreds of projects, programs or so. What was the work in process limits that they could use? Because we know that there's too much when everybody's just chaotic, there's multitasking, everything takes longer, you get much less done. But there's also too little work in process, where you're starting to starve critical resources in various locations. They simply didn't know, even the most experienced experts in critical chain didn't know what these WIP limits could be. And we said to them, you don't have to guess. You can use the model to run sensitivity analysis on this parameter and determine what is the best work in process limits for your environment. The second question that I had was, how do we control WIP? Do we control it at the task level, at a phase level, at a project level, or program level? Each of those have got pros and cons. How do I decide which one? Again, we said to him, you don't have to guess. You can run all these scenarios and we'll see. And that's what you'll see in the scenarios that we ran. We ran a baseline scenario that was based on following traditional project management rules. That includes traditional pipelining, start everything as soon as possible. It included traditional buffering, which means every task, every phase, every project is protected. It doesn't use aggregation of buffers. And as a result, you waste a tremendous amount of the safety that you've both added in terms of time and cost. And lastly, traditional execution is all about everything goes red quite quickly, and then how the hell do I prioritize? We leave it up to the local areas to decide. Compared to saying that we have some mechanism that will determine for us what the priority is from a systems level. In critical chain project management, we use this thing called fever chart, which is measuring the consumption of the project buffer and comparing that to the progress that you've made. If you're consuming the buffer slower than what you make progress, you're okay, it's in the green. If you're consuming your buffer both in time and cost faster than what you make in progress on your critical path, you're not okay and it's red. And immediately the whole system, that task that they're working on has a clear color level, and they just follow the colors. So the objective here was we wanted to use this as an example to test this platform that we've developed, completely self-configurable digital twin of a project environment. It doesn't care what the nature of the project is. We've tested already not just on gas turbines, we've tested it on banking, IT projects, we've tested it in construction. You read in the full work breakdown structure as a direct export from the project management system, you add in all the volatility and variability, the cost elements, and the model automatically configures itself. We had 4 scenarios that we're going to be running. The first scenario was, you've got this pipeline of 5 years, you're about a year into it, what's going to happen if you don't change the rules that you're using to plan and execute projects? You can imagine the high drama of presenting in front of the board and pressing the play button and them not knowing what's going to happen. And they see the clock running, and it's starting to approach this 5-year where everything had to be completed, and they're starting to see some of the projects and programs are starting to run late, and they're incurring penalties, there's no early bonuses, and that little 30% net margin was being consumed faster than what they had ever expected, and they don't know what's going to happen. We were given 8 weeks to prepare this simulation. Now we're at the point where we are presenting to the board. And it's high drama. You can imagine the people that planned these projects, made commitments, both operational and financial, were sitting there and they're waiting what's going to happen. You'll see on the results here, 20th of January 2022 was the expected completion of the full portfolio of these programs, projects, phases. They were expecting to make around $128 million of profit, about 32% net margin. So the sales and financial people were saying there's a lot of money here, right? If we need to catch up, we can throw resources at it. That's how we normally save these projects, and we still end up with about 10%. And the question was it enough? So we ran the first scenario, which is just following traditional project management, not changing the way that they plan and execute projects. And the results were not good at all. They ended up being over 2 years late, finishing 15th of February 2024. Rather than making $130 million, they lost $181 million. As I mentioned, we're not trying to be precisely wrong here, we're trying to be approximately right. Are you going to make about the money that you expected, more, less, or a lot less? And the result was very clear, a lot less. And now the question is, can you do better? Is there anything that we could do to be better? And that's why scenarios 2, 3, and 4 came in. Even for us as the most experienced field of constraints experts and project environments, we weren't sure what the best rule was to control the work in process in the system. Do we control it by project level, which is scenario 2? Do I control it by program level, which is scenario 3? Or do we use a hybrid? We control it by program level. We release program for program, only release a new one once another one has been completed. But we have a hybrid that says, if we notice that there's one location with a lot of resources that are now completely staffed, let's launch some additional projects to keep them busy. And the results were immediately very positive, is that we showed that you could, in fact, even though you're still going to be late on the total portfolio, you can actually make about $105 million on this. Despite being still a little bit late, you're going to be finishing in October rather than January. The big thing for them was, this is a swing of $286 million. That's massive. So the question was, can we do even better? So we tested it with scenario 3, which is controlling it at the program level. And we found out that, yes, this would make them profitable at least, but it's not as good as the previous scenario, which is only at the project level. And then the last scenario was a kind of a hybrid. We were hoping that this would be even better. It turned out that it's better in terms of lead time. So you can see here, this is 671 days earlier than the baseline scenario. But the financials weren't there. And what we realized is that the penalties and bonuses are not equally distributed, and we could run multiple scenarios that says you are going to get very good indications which projects are going to be late. So if you reprioritize, you can make sure that those that have big penalties or big early completion bonuses, that they are on time or early. And that gave them even better financial results. So that's how we ended up. What we've ended up with is now a digital twin for any project environment. You simply make an export out of whatever project management tool that you are using. It gives you your full work breakdown structure. You add in all the additional details that might not be captured there, like the variability in lead times, the costs, the bonuses, etc. And then you read it in and you've got the digital twin of your environment. So we'll end up here. It's been an extremely exciting project. We think that there's a lot of potential in exactly answering the type of question that I started with, right? Is we suspect that things are going wrong. We're getting early signals that we're going to be late. Do I need to panic? And I don't need a precise answer. I need to know, am I going to be early, on time, late, or very late? Am I going to make more money than I planned, about what I planned, a less or a lot less? And that's kind of the level of accuracy that we've seen that these models are capable of predicting.